since we are continuing the exercise 8.1, and in this lecture we will do or we will solve two questions from that exercise, question number 10 and 11. Right. So let us start with the question number 10. So in question number 10 it is given ABCD is a parallelogram. So first of all, this one ABCD is a parallelogram, right? And on this parallelogram, AP and CQ are perpendiculars from vertex A and C on diagonal BD. Okay, so let us first draw a diagonal BD. This is the diagonal. Now it is given AP and CQ are two perpendiculars. They are perpendicular. Perpendicular means a line which is perpendicular to another lines are known as perpendiculars, right? So AP and CQ are perpendiculars, and these are drawn drawn from the vertex A and the vertex C. It means AP is a perpendicular line which is drawn from A, on BD, okay, like this. Suppose this AP is the perpendicular line on BD. Similarly, CQ is another perpendicular line, CQ, which is drawn from C, on BD. This is CQ, and this is also perpendicular. Is it clear? So AP and CQ are two perpendicular lines drawn from A and C on the diagonal BD, and ABCD is a parallelogram. It is given, since it is a parallelogram, it means this side must be equal to this side, and this side must be equal to this side, and the pair of opposite sides are also parallel, right? Next, so if it happens, okay, then we have to show two statements. The first thing is triangle APB. This triangle is congruent to the triangle CQD. Okay, so let us prove the first statement, then we will move to the second statement, that this AP is equal to CQ, right? So let us prove. So in order to prove the triangle APB and the triangle CQD to be congruent, we have to compare them. So between triangle APB and triangle CQD, let's find the three possible conditions. Okay, the first condition is, see, for the triangle APB, AB is a side. For the triangle CQD, CD is a side. Yes or no? Yes. Can we write AB is equal to CD? Yes, we can write. Why? Because ABCD is a parallelogram and the pair of opposite sides are equal. Why? So we can write, since ABCD is a parallelogram. Right? This is the first possible conditions. Second condition is that, as you can see, AP is a perpendicular line on BD. Right? It means this angle is 90 degree and this angle is 90 degree. We know it. So we can write for the triangle APB, this angle is 90 degree. APB. Right. Similarly, CQ is the perpendicular line on BD. It means this angle is also 90 and this is also 90. So for the triangle CQD, this angle is also 90. So this angle is equal to this angle. So CQD angle is also 90 degree. Why? Because AP is perpendicular on BD and CQ is perpendicular on BD. Understood? Moving to the third condition. So according to the third condition, if we consider DC and AB as two lines, DC and AB as two lines, we already know these two lines are parallel. Okay, so if DB is the transversal line, then What is the relationship between this angle and this angle? Tell me. What is the relationship between this angle and this angle? These two angles are alternate pair of angles, and you know, if any two lines are parallel, there is a transversal line, then the pair of alternate angles must be equal. So what we can write? We can write this angle must be equal to this angle. Right? So we can write they are alternate interior. So CDP is equal to ABQ. ABQ. Why? Because they are alternate interior. Clear? So we have found three possible conditions here. So let us find which congruency does it follow. Right? So for the triangle APB, we have found this angle, and which side? And this side. This side. This angle, and this side. Clearly look at this. This angle, this side. It means it is angle, side. Not angle, side angle. No, because side is not included here. It is angle, side. Okay. So by angle, side criterion, this two triangle must be congruent. So you can write, hence by angle, side. Triangle APB must be congruent to which triangle? Triangle CQD. Understood? Is it clear now? So by AAS congruency, now these two triangles become congruent, and we have to also prove the first statement that the triangle APB is congruent to the triangle CQD, and here we have proved. So this is the proof for the statement number 1. Clear? Okay, so next moving to the proof of the second statement, that AP is equal to CQ. AP is equal to CQ. How we can prove? Okay, since in the statement 1, what we have proved? We have proved the triangle APB must be congruent to the triangle CQD. We have proved it. Now, for the triangle APB, AP is a side. For the triangle CQD, right? CQ is a side. Since these two triangles are congruent, since we have proved, that means their corresponding parts must be equal by CP. And here we have proved the second statement, that AP is equal to CQ. It is very easy to prove, right? AP is equal to CQ. Understood? Okay students, so again moving to the question number 11 of that exercise. According to question 11, it is given in triangle ABC and triangle DEF. So in this figure, as you can see, there are two triangles, triangle ABC and triangle DEF. And in this two triangles, AB is equal to DE. So this length AB is equal to this length DE. Clear? And AB is parallel to DE. So this line AB is parallel to this line DE. Clear? And BC is equal to EF. So BC, this length, is equal to EF, this length. Clear? And BC parallel to EF. So BC must be parallel to EF. And now the vertices A, B and C are joined to vertices D, E and F. So A vertex is joined to D vertex. So let's join them. Right. B vertex is joined to E vertex. So let's join. And C vertex must be joined to the F vertex. So C and F must be joined. Okay, so this is the final figure that we are trying to draw. So from the above data, we have to show that there are 6 conditions. There are 6 possible proof that we have to do. Okay, what are the statements that we have to prove? The first statement is we have to prove that ABED is a parallelogram. Second, BEFC is a parallelogram. Third, AD parallel to CF, AD parallel to CF. We have to prove that AD parallel to CF. Then SCFD, SCFD is a parallelogram. Fourth statement. Fifth statement, SC is equal to DF. SC is equal to DF. We have to prove. And the last but not the least, prove that triangle ABC is congruent to the triangle DEF. Okay, so we have to prove all those 6 statements by the help of the data that are given in this question. So let us start with the proof of the first statement, right? So proof of first statement that ABED is a parallelogram. ABED is a parallelogram. Now we know ABED is a quadrilateral. Yes or no? Yes. So in quadrilateral, ABED, right? We know that AB is equal to D, already given. AB is equal to D. So AB is equal to D. So this AB and D are the two, but they are the two opposite sides. We are considering this quadrilateral, and when AB and D are two opposite sides, and these two opposite sides are equal, it is given. Similarly, it is also given that AB must be parallel to D here. So and AB is parallel to DE. Understood? So in this quadrilateral ABED, what do we see here? We see that in this diagram, the pair of opposite sides, only one pair of opposite sides are equal as well as they are parallel. Understood? And we know according to the theorem 8.8, we have studied if in a quadrilateral any pair of opposite sides, okay, are equal and parallel, then it is a parallelogram. Okay, so what we can write? We can write hence implies ABED is a parallelogram. Why I have written this? Because in this quadrilateral AB is equal to D and AB parallel to D. And we have studied according to theorem 8.8, if in a quadrilateral, if any one pair of opposite sides are equal and parallel, then it is a parallelogram. Hence, you can write ABED is a parallelogram. Clear? Now it is proved that ABED is a parallelogram. We have proved it. Is it clear? And this is the proof of the first statement. You can write proved of first statement. Clear? Now moving to the proof of the second statement. How we can prove it? The second statement we have to prove that BEFC is a parallelogram. Okay, we will prove it. So how? So already we know that BEFC is a what? It is a quadrilateral. So similarly in quadrilateral BEFC, already we have BC is equal to EF in this quadrilateral. Look at this. Look at my figure. Okay. So here BC is equal to EF. It is given. So we can write BC is equal to EF. Okay. And it is also given that BC is parallel to EF. See, BC is parallel to EF. It is also given. So and BC is parallel to EF. So which two conditions we have found here? We have found in the quadrilateral BCEF. In this quadrilateral, one pair of opposite sides are equal as well as they are parallel. Okay, it is same condition as we have proved in the first statement, right? So here also and here also, one pair of opposite sides are equal and parallel. And you know, if one pair of opposite sides are equal and parallel, then that quadrilateral must be a parallelogram. So we can write that BEFC is a parallelogram. Okay, is it clear now? This is due to theorem 8.8, and now it is proved of the second statement. Okay, Clear? So take a screenshot of this. Next we will move to the third statement, that AD parallel to CF and AD is equal to, we will prove it, right? So first take a screenshot. Okay, so now I will erase. So in the third statement we have to prove that AD parallel to CF as well as AD is equal to CF. How? Since in the first statement we have proved, what? That ABED is a parallelogram. We have proved it, right? So this is B. ABED is a parallelogram. If ABED is a parallelogram, then we know pair of opposite side must be equal as well as they are parallel. So we can write that this side must be equal to this side. Yes or no? Yes, because ABED is a parallelogram. And this side must be parallel to also this side. Why? Because ABED is a parallelogram. So we can write, since ABED is a parallelogram, then AD is equal to B, AD is equal to BE, and AD parallel to B, AD parallel to B. Clear? Let's say this is our equation number 1. Understood? Now, in the second statement, what we have proved? In the second statement, we have proved that BEFC is a parallelogram. Clear? So BEFC is a parallelogram. If it is a parallelogram, then the pair of opposite side must be equal as well as they are parallel. So consider BEFC. This, only consider this figure. So here we can write that B side must be equal to CF side. Yes, B side must be equal to CF side. And BE must be parallel to this side CF. Clear? So BE must be parallel to CF. Let's say this is equation 2. Do you understand this? BEFC is a parallelogram. So here B is equal to CF and B is parallel to CF. Clear? Now we have to compare, or we have to analyze these two equations. So from equation 1, okay, consider this and this. Okay, for equation 1 we know that, from equation 1 and 2, both the equation we are considering, right? So here in equation 1 we know that AD is equal to what? B. And in equation 2 we know B is equal to CF. So we can write B is equal to CF. So what we have found here? We have found that AD, this side, is equal to B, this side, is equal to CF, this side. So these three sides must be equal, right? And consider this and this, right? So from the equation 1 we have proved AD is parallel to PF. AD is parallel to BF. Okay, so BE, not BF, it is BE. And in the equation number 2 we have proved B, this one, is parallel to CF. BE is parallel to CF. First of all, this is parallel to this, and now this is parallel to this. It means what? It means this must be parallel to this. Yes or no? See, BF is parallel to CF. So all these three sides, AD, BE and CF, are three parallel lines. Okay, done. Now, since AD is equal to B is equal to CF, so from this conclusion we can extract that now we can write that AD, this one, is equal to CF. Since all the three sides are equal, so we can write AD is equal to CF. Clear? And from this conclusion we can extract that AD is parallel to B, is parallel to CF. So we can write AD is parallel to CF. Yes or no? Yes, we can extract it out because all the three sides are parallel. So what we have proved here? We have proved that AD line or AD side is parallel to CF side and AD side is parallel to CF side. And this is the proof for the third statement. AD is equal to CF and AD parallel to CF. Is it clear? So now it is proved, and this is the proof of the third statement. We have proved all the three above statements. Now let us move to the statement number 4. Okay, so let us understand and prove the fourth statement, that ACFD is a parallelogram, right? So ACFD is a parallelogram that we have to prove now, right? As you can see in the previous statement, okay, we have proved that AD is parallel to CF as well as AD is equal to CF. Okay, so if we consider ACFD quadrilateral, then in this quadrilateral already we have proved that this side is parallel to this side and this side is equal to this side. So the pair of opposite sides are equal as well as parallel in this quadrilateral, right? Then what will happen? We know if in a quadrilateral any pair of opposite sides are equal and parallel, then it will be a parallelogram. Okay, so for this we have to first consider what? So for quadrilateral ACFD, okay, already we have proved that AD is parallel to CF and AD is equal to CF. In ACFD quadrilateral, this is parallel to this and this is equal to this. Okay, so one pair of opposite sides are equal as well as parallel. Hence, what we can write? ACFD is a parallelogram, simple parallelogram. And now we have proved the fourth statement, that ACFD is a parallelogram. Okay, so next we will move to the fifth statement to prove AC is equal to DF. Okay, AC is equal to DF we have to prove. How? See, already in the fourth statement of what we have proved? We have proved that ACFD is a parallelogram, isn't it? So in this parallelogram we know the pair of opposite sides are equal as well as parallel. So this side is equal to this side as well as this side is also equal to this side because they are pair of opposite sides. So we can write that this side of the parallelogram ACFD is equal to this side of this parallelogram. So we can write AC is equal to DF. Why? Because they are pair of opposite side of a parallelogram. Clear? So now we have proved the fifth statement that AC is equal to DF. Okay. So it is proof of fifth statement. Clear? Now coming to the last but not the least statement to prove the triangle ABC. Triangle ABC is congruent to the triangle DEF. ABC triangle, right? This is ABC triangle and DEF triangle are congruent. We have to prove, right? So for this we have to compare these two triangles, right? So between triangle ABC and triangle DEF. Okay, so already it is given the triangle ABC, AB side is equal to the triangle DEF, DE side, AB is equal to DE, already given. So we can write first possible condition, AB is equal to DE. This is given. Second, already it is also given BC side of the triangle ABC is equal to EF side of the triangle DEF. So BC is equal to EF. It is also given. Clear? Now just look at the third side of the triangle ABC, SC side, and the third side of the triangle DF side. Can we say SC is equal to DF? Yes, we can say. Why? Because already here we have proved SC SC is equal to DF. We have proved it that SC is equal to DF. That means this side must be equal to this side. It is proved already. So AC is equal to DF. Why? By proved. Here. So now we got three possible conditions. This stands for side, this stands for side, this stands for side. So by SSS congruency, this triangle is congruent to this triangle. Okay. So hence by SSS congruency, triangle ABC is congruent to the triangle DEF. This is the proof of sixth statement. And now we have proved every statements that has been need to prove. Okay.